Mattias Johansson is a JavaScript engineer at Spotify, and he writes about JavaScript on Quora and Twitter. Mattias, welcome to Software Engineering Daily.
Thank you very much, Jeff.
There is a graph you have posted in many of your Quora answers that shows how the most popular language in new GitHub repositories is JavaScript. And JavaScript has been on an uptick since 2008 and is now more popular than Ruby, Java, and other languages. What are the factors that are driving JavaScript's adoption?
Yeah, I get a lot of criticism for posting that graph because people say that it reflects GitHub specifically and web development specifically. But I think that JavaScript seems to be prolific in all kinds of fields, especially the Internet of Things. It's getting a lot of traction. And on the server side with Node.js. A lot of people think that JavaScript is getting a lot of traction just because you're forced to use it in the browser, but and to some degree, I think that explains its popularity, but not the entire picture, because people use it and seem to like it and use it on things where they don't have to use it, like backend things and Internet of Things. And it's also used as scripting language in Unity 3D, sort of. It's not really JavaScript, but it's close enough. And I discussed it with one of my colleagues. Why is JavaScript popular? Why is it? What's the reason for it? And I think it's just because there's something to it that makes it fun to write. I'm not a fan of PHP, but PHP is one of those things that focuses really, really hard on getting feedback to the user as fast as possible. You get something on the screen very fast, you get results really fast, and the language doesn't get in your way. And that's both a good thing and a bad thing, but one thing it does is that it makes it really fun to write. Also, JavaScript is getting a lot of traction from different areas because it has it's such I know that Brendan Eich was coerced or fooled into writing JavaScript as he was sold on, you're gonna write scheme in the browser. So it's it means that the language has a very strong functional heritage. So right now with React becoming popular, we have a lot of people that were previously uninterested in JavaScript getting into it because they realized, this is a functional programming language, sort of. You can write functional code in this. So there's a lot of people coming in from Clojure, and it's just a language. I think it's just a language where a lot of programmers meet. It's where a lot of paths intersect.
So we're going to get into the React stuff eventually, but so I want to talk a little bit more about the high level. I read a syllogism this morning from Eric Elliott where he said, quote, "Software is eating the world, the web is eating software, and JavaScript rules the web." So I guess so in this regard, this would sort of dovetail nicely into your critics who say, this just covers GitHub repositories, which is web development. Because what Eric is basically saying here is that, everything is going to be web development.
Yeah, was it... who said that? I think it's Atwood's law or something.
Yes.
That if something can be written in JavaScript, it will be written in JavaScript.
Yes, that's correct.
Yeah. I completely agree with that. That's the way it's gonna happen. I'm not sure if it's a good idea. I'm actually more certain that it's a bad idea to use JavaScript for everything. But I still think that we will do it. I mean, just because something is a bad idea doesn't really mean that we as a human race avoid it necessarily.
Well, why would you say that writing everything in JavaScript is a bad idea when you're such a big fan of it?
Just because you're a big fan of it doesn't mean that you're a fundamentalist, right? I like programming. I like a lot of languages. I'm really interested in Rust now at the moment. But the thing with I think people are searching for God in a way. You're looking for a savior, especially in JavaScript. You can see it in JavaScript frameworks, right? Everybody is confused that there's a lot of frameworks. There's a lot of tools, and people are confused. What tool do I use? So people eventually tend to converge and try to find this Uber tool that they can use for everything. And right now, that is, I think that's sort of Angular. But this is not a new tendency. It arises in all kinds of software development scenarios, such as, I think that SharePoint is another example of where people just converge on this single technology and use it for everything. WordPress is another example where you just, I worked as a consultant for a while, and I have seen WordPress being bent into the most weird shapes. People just want to find a single tool for stuff, and I think that is a bad thing to do. I mean, I love JavaScript, but I mean, there are cases where you just shouldn't do it. You should look at your problem and find and see what tool fits that purpose.
Okay, so in thinking about that, I want to discuss that as a motif throughout this conversation. But so when you look at the present trends within JavaScript, what are the predictions that you make about the future in terms of the tooling and just technology in general? What's going to happen in the future?
Yeah, I think that making predictions about the future.
We can come back to that in more.
No. I want to.
Okay, sure.
Okay, so
your most bold, ambitious predictions, regardless of the probability.
Yeah, exactly. No, one thing that you do when you predict the future is it's kind of colored by what you want to happen. So you want to see that. You tend to look at those scenarios, so this might not be this is what I want to happen, and what I'm looking for evidence of happening. And I think there is some evidence. I think that JavaScript will become the JavaScript that we will write in the future is going to be much more functional than it is today. The reason is that we are currently looking at a future in software development where CPUs are effectively approaching how much clock speed you can squeeze out of a single core. I'm not familiar with the exact reasons, but we're basically running out of molecular space. So what we're going to see is probably a lot more cores, which means that parallel programming is going to be much, much, much more important. And when you get into that, you start looking at, okay, why is parallel programming hard? Well, it's hard because mutable state. So people start avoiding mutable state, and then you start looking at what programming paradigms avoid mutable state. Well, functional programming avoids mutable state, and people become interested in functional programming. And JavaScript has a lot of functional stuff built in, and it has had that for years. So it just fits very well into it once you start doing it. And that is my one big prediction, that I think it's going to happen. We're going to get a lot more functional programming in JavaScript, and we have already. If you look at, for instance, the functional programming framework Bacon, it actually has more stars on GitHub than the Haskell compiler does. So I think that JavaScript is pushing functional programming already.
And does the Node.js event loop paradigm, the single-threaded event loop, does that fall in nicely with this future of functional and increased cores that you imagine?
No, I don't think so. I think that Node...
It's totally orthogonal.
Yeah. No, I don't think that Node... I mean, it's still... Node is... I'm not sure. I think that when you do like ultra parallel programming in Node, there's basically no facility for that. You just have to like spin that up into a hog ton of processes. It's tricky. It doesn't really have a strong facility for that.
Well, so that's kind of where I was going. Is I was thinking like, if we want to do this, separation of concerns across individual processors, maybe Node provides a good paradigm for that, because Node says, hey, this is a single thread, this is allocated to a single processor. I don't know, just paradigm wise, maybe that makes sense.
Yeah, sure. I think that Node has some. I don't think that necessarily that the future lies in Node. I mean, Node is when it comes down to it a very simple thing. It's just a V8 engine with some I/O welded on, really, and some libs. I think that if somebody invents something new that is more focused on parallelism. Is that the right way to say it? I'm not a native speaker.
Yes.
And then I think that the JavaScript community will move pretty quickly, because it's still going to be JavaScript, and I think that we're pretty fast at jumping on new things. Node is. Sure, it's nice with the single thread and just single thread, single process, and just have those processes intercommunicating. But the tricky part is that, yeah, that's fine if you have like a server farm. But let's say that you have, like in the future, you say that you have 1,000 processors or something like that on a single device intercommunicating. Then you run into the problem that you need to have a very low overhead in the communication between processes. And I think that you need to have more clever ways of dealing with that. I've just started reading into it. I was at a conference recently, and I ran into this interesting new programming language called Pony. That integrates actors as a language level feature, and actually checks for race conditions at a compile time level. So you can't have race conditions in your at runtime, because they're checked at compile time.
Oh, that's fascinating.
And yeah, I think that there is a lot of thinking to be done on the massive parallelism that we need to be facing, and I don't think that Node is the savior yet, but I think that JavaScript has, as a language, has some way to go past Node.
Okay, well, I appreciate the hesitance to call Node a savior, but I do want to talk a little bit more about Node, though. So Node allows JavaScript to be compiled, as I understand, allows JavaScript to be compiled directly to machine code through the V8, and this is kind of the big breakthrough. And this has driven an explosion of technologies built upon JavaScript, and I've been hearing the phrase JavaScript is the new bytecode. What do you think of that phrase?
If you asked me like a couple of months ago, I would have said yes. But a few weeks ago, or a month ago, or something like that, Brendan Eich announced WebAssembly. You know about this?
Yes. In fact, I was hoping you would have something to talk about, because on several episodes we've discussed WebAssembly vaguely, we've discussed ASM.js vaguely, and whenever I say, "Oh, so what do you know about this?" they're always like, I'm not really sure. I know it's big, but I don't know anything about it. So if you know anything, please, go nuts.
No, I don't. Let's discuss it vaguely and ambitiously.
Sure.
It's I'm in the same situation. It seems like WebAssembly is definitely this big, vague thing. It almost reminds me of when I started web development and I heard about XML. It was incredibly mysterious, and it was unclear what you used it for, and you just, what is this? So it's good to have that feeling again, something new and mysterious looming on the horizon. but no, I don't know much details about it except that it is what it sounds like. It's assembly for the web. So it's not a full-fledged language. It's just something that you can. It's an extremely primitive structure that you can compile almost everything down to.
Yeah, it's like a subset. It's like as I understand, it's like a subset of JavaScript, and it's just like, you compile all your JavaScript down to this subset of JavaScript, and it's just like, add one, right? It'll be like a function that's just like add one to something, and it's just like, the register language you learn about in your classes that are the whatever classes sit between electrical engineering and computer science, where they're just telling you these primitive assembly languages, and it's like it's a JavaScript version of that.
Yeah, precisely. The interesting part about it, from my perspective, is that a lot of people have tried to, replace JavaScript in many ways. But the interesting part about this is that it is, as you say, a extreme subset of JavaScript. So this will be able to execute on the existing JavaScript runtimes. It's going to be a pretty simple thing to convince browser makers to add support for this, unlike something like Dart, which is very difficult to get a browser maker to implement, because it would add a lot of complexity and a lot of work for very little benefit. But
not only that, sorry, I was going to say, not only that, but all the major players in the browser world are working on it together.
Yeah. Which makes it even more exciting that they have gotten people on board from the start. That's a pretty amazing thing. But the question that immediately arises is if this will this kill off JavaScript, and that's an interesting. Will people stop writing JavaScript? I don't know.
Yeah, because conceivably, if you could compile anything to ASM.js, then you could just write your stuff in Java, and you've got an ASM.js compiler, and then it's Java everywhere.
Sure.
We have
ASM.js. It works decently well in browsers. I mean, there's the Unreal Engine and Unity compiles to ASM.js, but we're still not really seeing that much use of it outside of the game programming engines.
Right. Okay, so talking a little bit more about Node, so there was recently a fork of Node called IO.js, and then eventually the two projects merged back together. This is a topic I haven't discussed much on JavaScript Week and Software Engineering Daily. Do you have any color on that? Do you know what the motivation was for the rift in the community and how they eventually came together?
Yeah, the reason that the fork happened was that some of the main contributors, and these were like the heavy names. For me, it was kind of like the contributors. I just figured, who is coding Node if these guys aren't? So it was a very, very, very big fork. I actually figured that IO.js would just win. But the reason that they did the fork was that they just felt that it wasn't moving fast enough. The ECMAScript 6 features were not being integrated quickly enough, which was basically because the Node.js didn't follow V8 as fast as they felt that it could be. So IO.js was the selling point of IO.js was basically ECMAScript 6 in Node now.
Okay, interesting. And how did they eventually come back together? What was the political situation?
I think that their intent was to merge it back together from the start. I believe that was their outspoken intent. There was never like, screw you guys, we're doing this on their own. I think that this was well, guys, we need to do this. We're gonna show you how. And then if you want to do it, we're going to do it on your ground in Node.js. But if you still want to do what you do, then we have to part ways.
Right.
I think it was just they made a statement there, and the Node enjoined and the Node Foundation that arose out of it. They listened.
Yeah, so I interviewed Yunong Xiao from Netflix, and it sounds like the Netflix stack is similar to that of Spotify, which is where you work. So there's a Java backend and JavaScript in the front end. And in the case of Netflix, it sounds like the JavaScript use cases were creeping more and more into backend-like functionality. So I'm curious how if that compares to how things are going at Spotify, and also like what is the dividing line between when a service should be written in Java and when a service should be written in JavaScript?
Our backend, as it stands now, and our tech stack is actually heavily influenced by a blog post that Netflix did a while back. I'm not sure how aware Netflix people are about that. But Netflix used to have these big...
Which blog post?
It's called...
Is it Node.js in Flames?
Maybe no. This is way earlier, several years ago. It's what they did. We will find it and link it in the show notes.
Sure, got it.
But what they did was they used to have this big generic API for everything that all apps used. The problem was that this was very difficult from a performance standpoint, because you had to, because the API was so generic, it didn't really know how the interfaces looked for each platform. So each platform would basically have to do a ton of requests to construct the view that they had. And what they ended up doing instead is to stick the generic API and let that remain on the backend, and then have these interim services, aggregation services that ran between the client and the actual more generic APIs that were aware of how the clients looked, like how the interfaces looked. So the requests that you made to these services was basically get the header view metadata. So you would get that. No other app ever would be using this endpoint. It was just to serve this specific view in this specific app. So the PlayStation app would have like a PlayStation endpoint, and that allowed them to move much faster and build much faster applications, because they split their former client logic into a bit into the backend. And these aggregation services, I think that those are what it would be really beneficial to write in Node, actually. We don't do it at Spotify yet. I'm trying to convince people. But the Java crowd is the Java power is very, very strong at Spotify. Let me tell you that.
The Java hegemony.
Yeah, exactly. It's a strong cabal.
So I mean, I'd love to hear more about that, like more about the Spotify versus Netflix. I mean, Spotify being similar to Netflix. I think that's really interesting, because it seems like at a fundamental level, these services are extremely similar. Like Spotify is the high-tech solution to serving music. Netflix is the high-tech solution to serving video to people.
Oh yeah, we're definitely siblings. It seems like we also prioritize user experience in very similar ways. I think that you see a lot of when you develop a software and you also use it a lot in your daily life, you become extremely aware of all its faults. There's a lot of stuff that just bothers me insanely about Spotify, which is good when you're you're a developer on it. But one thing that doesn't bother me is that we are ridiculously, absurdly good at just the pure streaming part of things. Almost all things tend to break before streaming songs with Spotify breaks. And it's the same thing with Netflix. It's just insanely good at just working. Just the pure streaming part, when you just play and things appear on your screen. I can actually watch. I have this tunnel to work where basically my phone dies completely. I can't browse web pages or do anything useful, but I can play Spotify remarkably, and I can watch Netflix. I can basically do nothing else. So we're definitely siblings in how we prioritize stuff, I think. So
and when you think about that prioritization of getting the streaming right, it's almost like you get the streaming right, and then you can build whatever else on top of that. But that's like the core functionality of the application. So I'm assuming that core functionality, the secret sauce, that's essentially written in Java.
Yes. Java has over time become stronger and stronger in Spotify. I think I've only been at Spotify for something like 3 years, but you kind of learn the history of things anyway. So before, when I joined, services were written in. You could write backend services in Python or Java. This has now kind of evolved into, you can pick either Python or Java if you pick Java. It's kind of like just become that. Yeah, Java is the choice for things. And I know that at the beginning, people were allowed to use whatever they felt were a good tool, which meant that the tech platform that Spotify had were like, Spotify has well over 100 microservices running in the backend, and back in the day, you had like tons of these written in completely different stacks, completely different languages, and it was. From what I heard, it ended up being quite a bit of mess that was really hard to maintain. As people,
what becomes hard to maintain when you have a heterogeneity between different services?
What do you mean heterogeneity?
Well, when you have services that are written in a variety of different languages, when you can just say I can just do this in whatever language I want. How did those problems manifest?
Well, I don't think that the problem are as much technical. I mean, we have this protocol at Spotify called Hermes, which is basically a proto-buff with some bells and whistles. I think the problem is more organizational and human. I think that if you have. If the tech platform, if everything is written in sort of the same way and with sort of the same tool on sort of the same infrastructure, it becomes very approachable for you to just move teams, or just instead of reporting a bug on a service, you can just let me check the source code and see if I can fix it. If you can just go in, if you can submit a pull request with unit tests and something that just fixes a bug, instead of trying to prod a team to fix something while they are busy with other things on the roadmap, you just become a lot more efficient employee. And if everybody can do that, your organization becomes much more efficient.
So you said that Spotify has over 100 microservices. What is your definition of microservices architecture, and how does it contrast to service-oriented architecture?
Yeah, service, I don't really know what service-oriented architecture means. I know that to me it's sort of like this term that a lot of overpaid CTOs at previous consultancy gigs I used to throw around, and we most certainly did not have a service-oriented architecture at those places. But at Spotify, when I say microservice, I basically mean a service that does one thing. At Spotify, we had an era at Spotify actually where we almost killed the organization by playlist. We built, like, I don't know if this is not general knowledge, but the playlist system at Spotify is by far the most advanced system that we have, because you can you can actually go offline and edit your playlist on several different devices. And when you connect back, the changes will automatically like merge and migrate, and it will work. And even if these are like a collaborative playlist owned by different users, and this feature set essentially caused us to write a small version of Git. It's just bizarre. So a playlist can actually be forked and have two different branches, and customer service will, well, you made these two changes, which one do you want? And so that kind of thing. It mostly does it automatically though. But either way, so we ended up with this general purpose and the general purpose store of URIs. The playlist system, it just stores lists, so you could stuff anything in there really, which was really handy. So you could just do. We did the inbox. The first inbox feature was built on top of playlists because it was so handy that you had this thing that instantly synced between clients, and everything was just handled for you. It was very alluring to build everything on top of playlists. But the problem was that playlist was not really built for this kind of load, and it was not built to be a generic type of database. So it put so much load on the playlist service that it was essentially down for long periods at a time because everybody was just hammering in it, and nobody noticed because it was still so good at syncing things, and a lot of people didn't use two different devices at that time. But we learned from that it's a really bad idea to have single services that have a lot of responsibilities. It's a lot better to separate things out into small services that do very few things, and preferably have as few dependencies as possible, because that makes it easier to maintain them, and they break in more predictable ways.
Why was it not a feasible solution to just spin up more instances of that playlist service so that you could serve the clients more aggressively?
Well, to some degree it was. I mean, we did, but it's not just a performance problem. It's also a complexity problem. I mean, a system that is essentially Git. I mean, that's difficult enough to maintain. It's a tricky. Not a lot of people knew how to maintain this system at Spotify. It was maintained by some of our very smartest people. And when you start welding on things like, for instance, starred is one of the more interesting design mistakes that we made. Starred is actually a playlist of playlists, and a playlist can have 10,000 tracks. Which means that you can, in theory, have 100 million tracks in your starred. And there are people that really put themselves put their souls into trying this limit out as much as possible. So
I'm one of those people.
Yeah. How many tracks do you have in your start?
Oh man, a lot. I don't have the exact number right now, but I mean I use that feature very aggressively, and I don't think it's probably not the best way to do what I do on Spotify, but it's one of those things where it's like I got into a habit, and now that's just what I do.
Yeah, I mean that's how you deal with that. That's what you do with software. You find a way to use it, and then you stick with it. We have this guy Bruno who has like 2 million tracks in his start. I'm pretty sure his client doesn't start. But either way, so and to add to this complexity, at some point we wanted start to be a set. So you can't, unlike the playlists are lists, right? But start is a set, so you can't add duplicate things to start. So there's a bunch of special logic welded onto playlists to handle these subtle use cases, and the same thing with Inbox, and there's also a bunch of other small services that have been built on top of the playlist system that have been deprecated and removed from clients, but there are still clients alive that uses it, so we can't remove it yet. And it just adds a ton of complexity to it. It's really hard to make these super generic systems. I mean, you just realize that, it was almost perfect to build start on top of this, but we want it to be a set, and we wanted to have more than 10,000 items, and you start doing all these little tweaks to make it work just right, and then you have a really complex service that isn't really fun to deal with.
Yeah, so that's fascinating. So I want to go back to the JavaScript world, and maybe this is a good segue. Like, I think Meteor is an interesting thing to discuss.
Oh, yeah.
And it kind of dovetails nicely because Meteor is something that looks at change sets and real-time collaboration as like a first-class citizen. And it's interesting because you just described this real-time collaborative playlist system, and this sounds like something. This is like exactly a use case that Meteor might solve. So, what do you think of Meteor?
Oh yeah, I really like Meteor. Meteor is just so nice. I think we have. Back when I was living in Stockholm, we had this thing called Stockholm Lounge Hackers, where we were a bunch of people that would basically just descend on a random hotel lounge, because we didn't have like a proper venue to do the hacks. So we just ended up there, and which was super nice. It turns out that a noisy hotel bar is somehow just conducive to creativity. And I remember one evening where we were like 20 people or something like that, and I introduced Meteor to a couple of people that night. They had not seen it before. And I remember that I had to take a phone call that was it was a pretty difficult phone call with like business stuff. So it took, I think it took like 50 minutes or something like that. So, and when I came back, the people that I have taught the framework to had basically recruited half of the table and built and deployed an app that they were constantly live deploying to. It was just amazing how fast and fun this thing is to write software with. You get things up running so fast. They offer a deployment platform, and you just it is so cool.
Yeah, I totally agree. And so I find Meteor fascinating because in some ways it's very opinionated, but in other ways it's completely agnostic. So when you go to write a Meteor app, there's very little code that's initially visible to the developer. Like, I mean, you've got the .meteor file that has all kinds of backend stuff, but that's not really visible to the developer. And this contrasts with Rails, because on Ruby on Rails, you start with a bunch of folders, you've got all these files. Yep. So Meteor is unopinionated in the sense that it starts you with just a single file that covers both the client and the server functionality, but it is opinionated in the sense that by default, your app is constantly updating the front end to sync with the database, and you can just one line deploy it. So what do you think are some other interesting aspects of Meteor that make it so compelling?
I think that Meteor is compelling. I really like the reasons that you mentioned, but I don't think that we need to praise Meteor more. I think that we need to talk a bit what Meteor needs to do better to be more used than it is.
Sure.
Because I figured that when I saw Meteor, I don't know exactly 2, 3, 4 years ago when it started arriving on the scene, by now I think that I would have expected it to have gone farther. And I think that the reason that it doesn't is for the same reason that I can't use it at Spotify. And that is that it is very, very full stacky. It's when you need to use Meteor, you basically have to do it all or nothing. It's really hard to integrate into something else. In theory, you could use other databases and all that whatnot, but it just doesn't slot into an existing stack. I think that is part of the reason why Angular is very very successful where other frameworks weren't, because you could just dump it into a part of your page and have it exist just there. It played very nicely with other things, and Meteor is something that you just have to buy into.
Right, I totally agree with that. And so let's use that as a transition to a discussion about React. So what's interesting about React and Meteor is that Meteor fits in perfectly with this idea of the Flux architecture that React talks about. So what do you think is the future of React, and does Meteor fit in with that, and how does React fit in versus Angular? I don't know, whatever you think is interesting about React.
Yeah. React is, I really like React. I really do. It took me a while because it looks so weird with the JSX syntax and stuff.
Yeah, that JSX is like you write a file that has JavaScript and HTML in it. Exactly.
It reminds me, I know that I used to code ActionScript back in the day, and they had XML as you could write XML in the language in just the same way that you write JSX. So it's not completely unfamiliar to me, but it's just, okay, this is weird, especially as a web developer, because you have been touted and it has been taught to you for years and years and years that you don't mix markup and code. That is something that web developers inherently try to avoid. But what I think that React just taught me, I kind of knew, but it taught me at like a fundamental level, is that just because you separate pieces of your logic does not mean that you have separated your concerns. It's very easy to take a bit of your code and put it in another file, and it feels separate now, but it probably isn't. There still is coupling between the two, and if there is, you just haven't done yourself a service by putting it in another file. You have just made things even more complicated. So I think that React, it's really nice that React just HTML and the view logic that generates it, they are intimately coupled, so it makes a lot of sense to put them in the same place. But either way, yeah.
Well, and so one of the biggest productivity sinks in software engineering is that for every application that you write, an engineering team has to write a web app and an iOS app and an Android app. And what's interesting about React and Meteor is that you can tell that they're thinking really deeply about how you can just write something in JavaScript and then basically deploy it to iOS and Android in a really usable fashion. I think this is one of the greatest the greatest things that they're working on. Do you think that this is like, is this going to be the long view of like how we break this awful duopoly of iOS and Android? Like, developers have to write in all these different languages.
Oh yeah, at Spotify we have this problem in like at grand scale. I mean, we have a ton of different platforms, and we currently do write everything natively. And we were one of the companies that really tried to make these things web views. We spent, I think we easily spent. We spent so much engineering time on that, it's scary. And then we just failed, just like Facebook did. I think that I'm really excited about React Native. I think that is a super interesting... Should we talk about what React Native is, perhaps?
Yes, please. I did a show about React, but in case people haven't heard it, please talk about what your view on React Native is.
Yeah, so React Native is basically the same thing as React, except that instead of rendering HTML, it renders native views. So you write these XML. You just render, instead of rendering HTML, you render these XML-like tags that represent iOS lists or iOS headers and stuff like that, and iOS buttons. So you are writing code specific for a platform. So it's not you're not writing one interface for every single device. But you are writing it with the same technology that you're familiar with. So it's not write once, run everywhere. It's learn once, write everywhere. And this is very interesting because it allows you to share JavaScript between your devices, but you don't use the browser to render stuff. Because that was always the problem. The browser and the DOM is just not nice enough to deliver that nice native mobile experience that is a reason why mobile devices are so popular and why everything is so nice. And we want to use that, but we don't want to rewrite our business logic and sorting logic and stuff like that every single time. That is logic that we want to share, and that is why React Native is so interesting, because it allows you to use this shared JavaScript core that runs on all of the devices and is also easily deployable and updatable, and have that control a very, very thin layer of native stuff for every platform.
And talking more about just the present day React.js, how does React.js compare to Angular.js?
I think they're two very different things. React is Angular is this pretty big thing. It was a prototyping framework. A lot of designers really like, many of my Codey designer friends, they really like Angular because it just allows you to get something up and running very fast, and it's obvious where to plug things in, and there's a lot of plugin architecture, and it's pretty darn opinionated, and it gives you like a ton of structure, and it's also built around I get the feeling that it's intended to be a front end on top of a REST web service. There's a lot of REST stuff going on in it. It's sort of there's a lot of, it's not like Rails, but there's a lot of reminiscing about Rails in it, and it's also very familiar to somebody coming from Java. It's very obvious to me that this is coming from Google, where you use Java a lot, and there's a lot of stuff going on there that is to me, a bit weird that you introduce into JavaScript, personally. React, on the other hand, does almost nothing. React is just a framework, not even a framework, just a little library that allows you to render a virtual DOM and have that rewritten as a real DOM. And the whole advantage with React is that you can just re-render everything all the bloody time and not have to bother with the expense of doing that so much. So you can just write your code declaratively and nice, just whenever this changes, just re-render the whole thing, which allows you to skip a lot of complexity in your code because there's a lot less state to worry about. And you just re-render the entire virtual DOM, and then it just does a diff between that and the real DOM and figures out what has changed, so it can do it the minimal surgical impact on the DOM and make that performant. And that is really all that React does.
Right. So to begin to close off, we've got about 10 minutes left or so. I want to talk a bit about your philosophy of programming, just in a broader sense. You answer many questions on Quora when people ask about how to learn to code. When somebody comes to you and says, I wish I could learn how to code, but I'm not smart enough, or I am afraid of coding, or I'm not good at math, how do you respond to those people?
Well, I'm not good at math either. My background is actually in theater. I'm not a computer scientist. I started learning programming because I don't know. I was just interested in something. I think it was I was interested in mnemonics. How to memorize things, how to do stuff like memorize a set of cards, or how to remember the first 200 digits of pi and all that stuff. It's a lot of techniques there that the Greeks invented like a couple of thousands of years ago when they were burning books. So I was really into that, and I wanted to make a website about that. So I learned this. I just picked this thing up called PHP Nuke, which was basically WordPress, but extremely much more horrible. And I just managed to just gradually started like doing little tweaks to it, and started bending stuff to my will, and that is. And that just snowballed, and after a while I was a programmer, really. I am a big proponent of doing and just learning as you go. You just need to decide what it is, like get this picture in your head of, I want to make this. I want to get this thing in my mind out into the real world. And then you just figure out, how can I take one step? And you're going to run into a problem. And then you're going to solve that problem by just Googling it or just banging your head into the problem until you fix it. And then you figure out how to take another step, and so on. I think that people should not be so much focused on just learning programming. They should be focused on a problem, something that they would like to solve, and then just let programming be a consequence of that. So I never learned programming, really. I just did things, and programming came as a consequence.
And your writing and your videos are so good because you have the flair of an artist and the flair of a theater person, but you also have the craftsmanship and the attention to detail that an engineer has. So, do you think that this distinction between art and engineering is a false dichotomy?
Oh yeah, absolutely. And thank you so much. It makes me feel so good. No, I think there is a sad separation there. I really do. I think that there is room for, like, how do you... There's a term going on, right? there's a term that is used a lot that I really dislike, and that term is called real programming. How do I become a real programmer? That's not real programming. HTML is not real programming. JavaScript is not real programming. And like 20 years back, I bet that people were saying that C++ was not real programming because it was not assembler. And before that, I don't even know what kind of sticks you used.
Yeah,
before
if you're not using vacuum tubes, it's not real programming.
Yeah, exactly. And right now, and to a certain degree, I guess that's true. I mean, you cannot get a job at Google if you don't know how time complexity works and knows how to just do basic computer science problems. But I think that there is a room nowadays for a vast array of different kinds of classes of programmers. I mean, some programmers are gonna like to work downwards in the chain, right? You have C++ and you learn to go down and you go down to, like, I know a guy who, when he studied computer science, I got to program CPUs by putting putting just electricity to the pins on the CPU, and that's pretty cool, working down the chain. But a lot of people are also going to learn a programming language and work upwards in the chain. They're going to do something. There's this thing called hack design, which is a place that teaches design for programmers. And then perhaps there's people move up to learning about user testing and learning a bit about how to do product development. And they move in that direction of the chain. So making an application is such a ridiculously complicated thing that involves so many different disciplines if you're going to do it right. And to do it efficiently, you just need a lot of people, and you need a lot of people to cover all that overlap. And I figure that why not? It makes a lot of sense that a lot of the people there know programming. It's just very helpful if a designer can do a lot of programming on their own instead of just, could you please move this button 2 pixels to the left? I mean, there's a lot of efficiency there if the designer can do that on their own, and just I think that we need to realize that programming is a very vast profession that allows for a lot of different degrees of competency.
And as somebody with a strong aesthetic and a strong desire to express yourself, how do you fit into a large company like Spotify?
Yeah, chaotically, I guess. I always said Spotify is one of the best companies that I fit into, but generally I have a hard time fitting into a corporate culture because I don't know, I feel very weird in almost every role because my skill set is pretty broad. I used to run my own company where I did basically everything. I not only did design, I did marketing, and I did bookkeeping, and I did business strategy, and I just learned to meddle with all kinds of things. And I don't think that to be honest, I don't think that I've learned to fit into a corporate culture as good as some people have. There's some people are way better. I know that Rasmus, that was the head designer at Spotify, and he moved to Facebook for a while, and now he's at Dropbox, I think. And you find him at rasmus.me or something like that. He's also a coder. He does things like he developed this little editor called Code, K-O-D, and he made a blog post where he developed his own programming language, and then he does all this stuff on design. So he's very broad, but I don't know. I have not managed to fit that well into the corporate culture as he is, and I think that because designers have more freedom to move a bit. They can move into product, they can move a bit into code, but it's a lot harder for a programmer to move a bit into design or move a bit into product. I think I've chosen an unfortunate starting point.
That's great. Well, okay, Mattias Petter Johansson, thank you so much for coming on Software Engineering Daily. It's been a real pleasure talking to you.
It's been awesome. Thank you.